Right, hello. This is a video for Unit 12, Day 6. You should have two pieces of paper. You should have this warm-up that's called Graphing Logarithmic Functions, and you should also have a note sheet called Solving Logarithmic Equations. So start with the warm-up, which is a little bit of review, but is a little bit of something that we actually need to know for this unit, so it's kind of notes at the same time. It says, consider the function h of x equals log base 2 of x plus 8. It says, algebraically determine the domain of h of x. And we talked about domains previously in class. Remember, log domains, logs, you're allowed to put what inside a log? You're allowed to put positive numbers. You can't put negatives or zero. So whenever you're asked to determine the domain of a log, take whatever's inside the log, in this case x plus 8, and set it greater than 0. So this one's a pretty easy one to solve. I can just subtract the 8 over. I don't have to partition or anything like that. I get x is greater than negative 8. And I didn't specify what form to write it in, so that's an acceptable answer. If it had asked for interval notation, which is what I normally prefer, here's negative 8. It's got to be strictly greater than, so not including negative 8, but anything bigger. So that would be parenthesis negative 8 to infinity. Okay, now keep that in mind because that's going to be important with the work that we do in the notes today. Log domains, you can't be negative or 0. Can't be negative or 0. We'll come back to that. Okay, part B said graph h of x equals log base 2 of x plus 8 on the axes provided. It says hint, use your graphing calculator to complete the table of values below. Okay, so if you go to your calculator, and I have an old one here, so if I type this into y equals, I don't have that fancy log base key that's on the newer calculators. If you have a newer calculator, remember you can go to math and scroll down and you should see log base. I think it's math 0 or math A, something like that. But if you have an older calculator, remember how you actually type in log base 2 of x plus 8 is by typing log x plus 8, divided by log 2. And whether you have a new or old calculator, you can do it this way. I'm going to go to my table, but first I'm going to make sure it's set up on ask so that I can type in whatever values I want. And then I want negative 8, negative 7, try that again, negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, and 0. All 0 I have to come back to. So if you notice negative 8 is an error, which should be no surprise. And that's because if I put a negative 8 here, log of 0 is undefined, so we're not going to have that graphed at all. Starting with negative 7, I do have answers. Negative 7 is 0, negative 6 is 1. So if I've got 0 and 1, negative 5 is 1.585, negative 4 is 2, 1.585, and 2. Negative 3 is 2.32, negative 1 is 2.8. Oops, forgot negative 2 in there. Let's put that back in there. So negative 3 is 2.32, negative 2 is 2.585. 2 and 2.585. Then I need negative 1 and 0. So delete out a couple of these here. Negative 1 is 2.807 and 0 is 3. So 2.807 and 3. Okay, now we want to graph these. So negative 7, 1, 2, 3, 4, 5, 6, 7 is 0. Negative 6 is 1, 1.585, 2, that was 2.32, 2.585. It's growing slowly. By the time I get here, it's 3. So if I just connect that piece of it, that's the graph that I get. Now if we look at the graph in the calculator and compare it, I go zoom standard. That's basically what it looks like. It does go off forever in this direction. since it's an error everything to the left, remember on day 1 of logs had vertical asymptotes at x equals 0. And that's because you couldn't be 0 or negative inside a log. Well, in this case, -8 is the first value that causes an issue, because that's the value that makes the log 0. So the vertical asymptotes at x equals -8. So that means this graph actually goes down forever this way here. Okay, so that's what your graph looks like. Now, question C says, what transformation applied to f of x equals log base 2 of x would produce the graph of h of x? So they're saying that if the parent function was log base 2 of x, how would you get log base 2 of x plus 8? So essentially, what would this plus 8 do to the graph? Well, you can tell that originally, let's take it out for a second. If I take out this plus 8 and look at what the graph looks like, we have the same basic shape, but it stops here at 0. So if I compare these two graphs, what happened to the blue graph over here? Well, it got shifted to the left. And that makes sense because x plus 8 means shift 8 to the left. So transformation would be officially it's translate 8 left. It says, what is the x-intercept of h of x? Well, x-intercept is what happens when, how do you find any x-intercept ever? It's when y equals 0. And if I plug in 0 for y, we'd have 0 equals log base 2 of x. And we can look in our table and we see that when y is 0, x is -7. And you can see that on the graph too. It's definitely the x-intercept. So the x-intercept is, is -7, 0. Today we're going to be dealing with log equations, so we'll be able to solve this more specifically. Really, remember, how do you get rid of a log? You exponentiate. So if I exponentiate both sides by 2 here, those would cancel. I'd get 2 to the 0 equals, oops, and again, sorry, so I made another mistake here. This really was, I was setting 0 equal to my h of x, so log base 2 of x plus 8. Sorry about that. So I would get 0 equals, since the logs canceled, x plus 8. What's 2 to the 0? It's 1. So 1 equals x plus 8. Subtract the 8. You get that x is -7, which we saw graphically and with the table. When it says what's the y-intercept of h of x, how do you find any y-intercept ever? That's when you set x equal to 0. So if h of x is this log base 2 of x plus 8, if I set x equal to 0, we have y equals log base 2 of 0 plus 8, which is just log base 2 of 8. And we can see graphically the y-intercept appears right here at 0, 3. We can see it in here too when x is 0, y is 3. But algebraically, you should be able to do log base 2 of 8. Remember, what does a log mean? It means what exponent goes on the base of 2 to get to this number 8 here. And the answer would be 3. 2 cubed is 8. So the y-intercept is 0, 3. Okay, so graphing logs, not going to be super important, but it is a nice idea to remember and to connect this idea that wherever the domain begins, so at greater than -8, that's where the asymptote is going to be. So if my domain is -8 to infinity, I have an asymptote at x equals -8 because I can't be anything less than that, or -8. Okay, let's switch over to the notes. So you should have this sheet. And again, today we're solving logarithmic equations. So there's 3 basic steps. It says use log properties to get no more than 1 log on each side of the equation. So you can't have multiple logs. Like in example 1 down here, I've got log base 3 of 2 and log base 3 of 7 on one side. Can't do that. So we're going to have to use log properties, which is, 2 logs added becomes 1 log multiplied in this case, to make that have no more than 1 log. It's okay if you don't have any logs on the side, but no more than 1 log. Next step is exponentiate to get rid of logs. And then we're going to solve the resulting equation. But since the domain of logs isn't negative infinity to infinity, there's rejection issues, or respectfully decline, depending on what you want to say. Similar to radical equations. Radicals also don't have all real numbers as their domain. That's why we have rejections. So we got to check answers, may need to reject if not in the domain. The key to remember here is what can't you have in a log? You can't have take the log of a negative number or 0. So you can't take the log of a negative number or 0. Okay, so let's use those steps to solve question 1 down here. It says log base 3 of 2 plus log base 3 of 7 equals log base 3 of x. So first step, use log properties so there's no more than 1 log on each side of the equation. Right now I've got 2 logs over here, and that's definitely not allowed. So what log property can we use to combine this into 1? 2 logs added is 1 log multiplied. So this would become log base 3 of 2 times 7 equals log base 3 of x. And you can do that step in your head. Log base 3 of 2 times 7 is really just log base 3 of 14 equals log base 3 of x. Okay, so we've satisfied step 1, no more than 1 log on each side. Second step, exponentiate to get rid of the logs. Okay, so if I exponentiate, what would get rid of the logs here? If I exponentiate by what number? Exponentiating by 3. So those cancel, those cancel. On the left, I'm just left with 14. On the right, I'm just left with x. 14 equals x. Nothing to solve there. So my equation answer looks like 14. But we have to make sure that the answers don't give us a log of a negative number or 0. Now 14 is obviously not negative or 0, but that's not what I'm talking about here. I'm talking about if I take 14 and plug it into any of these equations where x is, would it make that resulting log negative or 0? So just because the number is positive doesn't mean it's safe. But if you plug in 14, obviously the only place you can plug it in is right here, and that's not going to make the log negative or 0. So no rejection here. 14 is our answer. Now, as always, it's an equation, so if you wanted to, you could check your answer on a graphing calculator. So how do you always check an equation on your calculator? Doing y1, y2. So I'm going to put log base 3 of 2 plus log base 3 of 7 into y1 and log base 3 of x into y2. So that's all going in y1. That's all going in y2. And remember, since I have an old calculator, I can't use that log base key. But if you do have a new calculator, you can use log base to type this in really easily. I'm going to have to type it in as log of 2 divided by log of 3 plus log of 7 divided by log of 3 using that base change formula. Then y2, I'm going to put log of x divided by log of 3. And then I'm going to go zoom standard. And really this y1 is a straight line because there's no variables over here. So these are all numbers. Log base 3 of x is going to be an increasing graph. It doesn't quite connect, so I'm going to have to adjust the window. So if I make y max 20, we know I should be looking for 14. So I said y max, x max 20. Hopefully I'm going to see these connect at 14 as I'm expecting. You can kind of cheat with the window if you know what you're supposed to get. So second calc intersects, first curve, second curve, guess, and there we go, intersection at 14 in this crazy y value, but it's the x value that we were looking for. So if you want to show a check, make sure you show it with a graph. We went to 14 out here. Well, I guess we actually went to 20. And these we kept as negative 10 to 10. But it looks something like this. And that was 14 and whatever. So it checks. Okay. Obviously they'll get a little trickier than that. Let's go down and try number 2. We got log of x plus 2 plus log of x plus 5 equals 1. What's the first step? You can't have more than one log on each side of the equation, so don't go exponentiating. The biggest mistake people will make is exponentiate from this step. Incidentally, what is the base here? There's no base listed. Right, it's 10. So if I were to exponentiate to get rid of the logs, we'd have to do log base 10. But don't do this. Don't write this. Do not write this. Make sure you're not writing. Are you writing? Don't write. That's totally bad. Super bad. Totally wrong. If you ever do that, throw down your pencil and run to Math Assistance because you have no idea what's going on. You cannot exponentiate by 10 twice on one side, once on the other. It doesn't work that way. So don't do that. Instead, combine these. So again, 2 logs added becomes 1 log multiplied. So it'd be log of x plus 2 times x plus 5 equals 1. We need to multiply those out, and we do that using the box. So I'm multiplying x plus 2, x plus 5, so that'd be x squared, 2x, 5x, and 10. So this is really log of x squared plus 7x squared plus 10 equals 1. Now I don't have any more than 1 log on each side, so I can get rid of the log by exponentiating. And again, we're going to exponentiate by 10. So those cancel. I'm left with x squared plus 7x plus 10 equals 10 to the first, which is just 10. How do you solve an equation with a quadratic? We've seen those a bunch this year. You want to bring everything over, make it equal to 0. So it's going to cancel out that 10, make it x squared plus 7x equals 0. Then we factor out the x, leaving us with x plus 7, GCF there. And we end up with x equals 0 and x equals negative 7. Now I can't take the log of a negative or 0. Now my answers came out 0 and negative. So do I have to reject both of them? No. Because remember, it's only if the answers make the original logs negative or 0. Then if I plug 0 in, this is log of 2, this is log of 5. No problems there. Those are both positive logs. So 0 is an answer. X equals negative 7. If I plug in negative 7, does it make either of these logs negative? Well, it actually makes both of them. Because this would be log of negative 5, this would be log of negative 2. So if it makes either of them negative, it's no good. We have to reject or respectfully decline. So negative 7 cannot be used. And if you want to make a note why, it's because log of negative 7 plus 2 would be log of negative 5. Can't have a negative inside there. Okay, so if I wanted to, I could check this on my calculator as well. You'd see the only solution is at 0. Save time, I'm not going to do that, but remember we could do y1, y2. This one would be pretty easy because it's new calculator or old, you can use the log key. Okay, down to number 3. Number 3 is a mini one. Log of x equals 3 log of 2. Now again, I can't exponentiate by 10 to start out with. It's this 3 is messing me up. If I put a 10 here right now, this log and the 10 would not cancel because that 3 is in front of it. So what could I do with the 3? Remember, you can put it inside the log by making it an exponent. So this 3 is going to come up here, and that's going to give us log of x equals log of 2 cubed. And what is 2 cubed really? Right, log of x equals log of 8. Now I can get rid of the logs by exponentiating by 10. So log cancels, we're left with x equals 8. Before I circle it, let me check. It's just log of 8, that's totally fine. So x equals 8 is our answer. Okay, so in that case, putting that exponent in allowed me to cancel the logs. Depending on the situation, that might not always be the best scenario. We'll come back to that idea in a second. Okay, ready to go on to the next page? Here we go. ln of x plus 2 equals ln of 12 minus ln of x plus 3. Okay, what's my first step? Hopefully you're saying combining this side, because I have 2 logs over there and that's not allowed. What does 2 logs subtracted become? 1 log divided. So this side is just going to stay ln of x plus 2, but this side is going to be ln of 12 over x plus 3. Okay, now how do I get rid of an ln? Well, remember, ln is really log base e. So I'm going to exponentiate both sides by e here. So cancel, cancel. Now I have x plus 2 equals 12 over x plus 3. Okay, now I've got a rational equation. Any ideas what to do? How could you get rid of this x plus 3? You could multiply both sides by it. So multiply both sides by x plus 3. So those cancel. So now I just have 12 over here. Remember, those are just canceled, so I don't have to do 12 times x plus 3. These have to get multiplied, and you can use the box if you need to, but it comes out to be x squared plus 5x plus 6. Got another quadratic, so move that 12 over. X squared plus 5x, it'll be minus 6 when I subtract the 12, equals 0. Then we're going to factor. And you can reverse box if you need it. This is going to come out to be x and x. It's got to be plus 6 and minus 1 to end up with a positive 5 and a negative 6 on the end there. Come up over here. So when I draw the wall, we're going to get x equals negative 6 and x equals 1. Are both of those okay? Well, if I plug in negative 6, that makes this log negative. So without even checking anything else, negative 6. We've got to respectfully decline, unfortunately. 1 plus 2, that's log of 3, that's fine. 1 plus 3, that's ln of 4, that's fine. So 1 is totally fine. So again, the reason I rejected this wasn't because it was negative. It was because if I did ln of negative 6 plus 2, if I plug that in, I got ln of negative 4, soup bad. Okay. Number 5, not all that different. I've got 2 logs subtracted, no logs on this side. My first step would be to do what? Hopefully nobody said exponentiate by 2, because that'd be so bad. Instead, I'm subtracting these 2 logs. So 2 logs subtracted becomes 1 log divided. So log base 2 of x plus 5 over x minus 2 equals 3. And now what? Now I can exponentiate. So now I exponentiate by 2 to get rid of that log base 2, giving me x plus 5 over x minus 2 equals 2 to the 3rd, which is what? It's not 6, it's 8, 2 cubed. Then what? Multiply both sides by x minus 2. So I have x plus 5 equals 8x minus 16. And this isn't squared, so I can just move stuff around and get x alone. So if I subtract an x over, I'm going to have 7x on this side. I add the 16, I'll have 21 over here. So divide by 7, you're going to get 3 equals x. Is that okay? 3 plus 5, that's log base 2 of 8, that's fine. 3 minus 2, that's log base 2 of 1, that's fine. So x equals 3 is our answer. No rejection necessary. Okay, getting close to the end. Let's go down to number 6 here. Log of x plus 2x plus 5 squared equals 4. Okay, so can I exponentiate right away? Yes, because there's no number out front. There's only 1 log outside already. They've already put the 2 in as an exponent. Isn't that nice of them? So I can exponentiate, and we'll get rid of that log. Exponentiating by 10. So those would cancel. And I would be left with 2x plus 5 squared equals 10 to the fourth. 10 to the fourth, which is 10,000. Now 2x plus 5 squared, remember that's not 4x squared plus 25. We'd have to box that out. To save time, it would end up becoming 4x squared plus 20x plus 25. And again, if you're unsure how I jumped that, draw out a box and you can see that that's what it would come out to be. This side is 10,000. So I've got a quadratic, so what do I need to do now? I need to subtract the 10,000 over, so that would give me 4x squared plus 20x minus 9,975 equals 0. Now what? Well, this is not an easy thing to factor. You could reverse box it, see if it factors. If it doesn't factor, what can you always use when things don't factor? Quadratic formula. But it's pretty gross. So I'm just going to say ew. Could use quad formula. And that would get you to the answer. You might have to reject a solution. Or there's another option. Now remember a second ago, a little bit more than a second, but we had an easy question with an exponent a minute ago on the front page, this one. I had to put that 3 in so I could take the log of both sides. But I had logs on both sides in that case. In this case, only one side has a log. So what if, instead of leaving that 2 in, which just seemed like they were nice to put in, but really they were being jerks, what if I had taken that 2 out front? Let's try this. So bring the 2 out. So 2 log of 2x plus 5 equals 4. I can't exponentiate by 10, but what can I do? Well, I can get rid of this 2, and rather than putting it in as an exponent, since there's no log on this side, I can just divide by 2. So now I have log of 2x plus 5 equals 2. Now what can I do? Well, now I can exponentiate by 10, but the advantage now is we don't have this squared like I did in the last time I did it. So now I just have 2x plus 5 equals 10 squared, which is what? 100. And if I solve, subtract 5, 2x equals 95. X equals 95 divided by 2. And it's definitely not going to make this log negative or 0, because when I put in 95 over 2, it's actually going to be 100 squared, so definitely not a problem. So that's my answer. I didn't ever have to use quadratic formula, didn't ever get this crazy quadratic, didn't have to box anything out. So there's no hard and fast rule on how to deal with these exponents. And that's why you kind of got to really know the math and try different things and see what works the best. Okay, let's finish it off. We got one more. Example 7. ln of x squared plus 7x plus 12 minus ln of x plus 4 equals 0. What have I got to do first? Hopefully well, there's actually 2 ways to go about it. But I'd probably think 2 logs subtracted, 1 log divided if I follow the rules. So this would be ln of x squared plus 7x plus 12 over x plus 4 equals 0. Then what? Get rid of the ln by exponentiating by e. So then I've got x squared plus 7x plus 12 over x plus 4 equals, what's e to the 0? 1. I've got a fraction, so how do I deal with that? Multiply. So multiply both sides by x plus 4. That gets it to cancel over here, leaving me with x squared plus 7x plus 12 equals x plus 4. We got to set it equal to 0. So x squared, subtract the x, plus 6x Subtract the 4 plus 8 equals 0. Factor x plus 2, x plus 4. It's going to give me two negative answers. X equals -4, x equals -2. Do either of those need to be rejected? -4 I definitely see as a problem, because ln of -4 plus 4, that's ln of 0. You can't have the log of a 0. So -4, fortunately we're respectfully declining that one. But -2, no problem here. And if you check, -2 squared is 4, plus 7 times -2, so 4 plus -14, it's -10. But when I add the 12, it's positive. So x equals -2 is okay. And that's our answer. Okay. So that's pretty much it. You're pretty much ready to go. If you have any questions, feel free to stop by and see me tomorrow at some point. Remember, homework is a worksheet. Hopefully you all have it. If not, it's on my website, so you can download it and print it off there. Check your answers on your answer key, and good luck.